You wake up in your ultra-modern dwelling, go out on the balcony, and admire the incredible sandstorm in the distance. The reddish wall is approaching and has already reached the parking lot where your shiny Starship rocket stands. When the storm subsides, you put on your spacesuit, get in your rover, and drive to work. Your job today is to monitor the instruments in the freshwater extraction plant. In the evening, your shift ends and you return home. The cooking robot has already prepared dinner, fried potatoes, grown right here on Mars. This scenario could be true as early as 2050 and even sooner. Elon Musk plans to send 1 million people to Mars by then. Very ambitious, but incredibly difficult to accomplish. Flying to Mars is very expensive and time-consuming, and it consists of several stages. We're heading to the launch pad, where the first Starship is being prepared for takeoff. The rocket consists of 2 parts. The first is the Super Heavy booster. It'll help the heavy craft overcome the Earth's gravity and leave our planet. It should take Starship into orbit, then undock and land back on Earth. At that time, Starship has to hover in orbit, having used up almost all of its fuel during takeoff. The next step is to refuel Starship right in orbit. The booster takes off again from the launch pad and carries fuel for the main spacecraft. Starship is still empty because we don't want to spend a lot of fuel to lift it out of orbit. So now, it's time for another booster rocket to carry a payload for Starship. Food, construction materials, and research equipment are stacked in the cargo bay. All set at last, our spaceship sets off on its long journey towards Mars. This is how just one ship is planned to be launched, but it can only hold 100 people, while we're planning to send 1 million there. That's almost half the population of Brooklyn. That means we'll need at least 10,000 ships for the whole mission, and even more booster rockets to refuel and send cargo into orbit. Considering that one Starship costs about $8 billion, this mission would cost a pretty penny. The key to solving this problem is reusing these ships. Once the ship has delivered people to Mars, it should be refueled and sent back to Earth for the next batch, sort of a space bus. Another problem is time. The orbits of Earth and Mars aren't perfectly circular. They're of different lengths and make circles around the Sun at different speeds. When Earth and Mars are at their farthest apart, the distance between them is about 248 million miles. And the closest distance, when the Earth is perfectly between the Sun and Mars, is 34 million miles. This is our target. Once every 26 months, Earth and Mars meet at this distance, so this is the perfect time to launch a rocket to keep the flight time as short as possible, between 6 and 8 months. If the first flight is scheduled for 2025, and we plan to complete the mission in 2050, we would only have 12 such flight windows. We would need to launch at least 833 ships in each window. Then there's weightlessness. On a trip to Mars, astronauts will spend more time in zero gravity than people now spend on the International Space Station. Without gravity, people's muscles weaken. Even the distance between their vertebrae slightly increases. So, during the missions, astronauts actually become a bit taller. Throughout the voyage, the team will have to constantly train in the gym to be ready for the hard work upon arriving on Mars. In addition to ships with people on board, cargo ships will also be needed. When people arrive on Mars, they will need to build an entire city from scratch. Construction materials, tools, machines. The massive cargo Starship can take on board is about 75 tons. That's about 30 SUVs. So, we'll need a lot more ships to get everything we need. And that doubles the cost of the whole mission. There's a cheaper way to get to Mars, though. The Gateway Station on the Moon. It's kind of like the ISS, only it orbits our natural satellite. It'll also have many modules for astronauts, living bays, storage bays, docks for ships, and research units. The whole point is that it's much easier for a spaceship to launch from such a station because there's no gravity. And then, the ship doesn't have to use an incredible amount of fuel to leave the Earth's atmosphere. It took about $100 billion to build the ISS, and building Gateway could be even more expensive. But it should save us money in the future. The small Orion spacecraft will lift astronauts from the surface to the station. Then, after preparation, the astronauts will go on a long journey to Mars. Let's go a little bit forward in time. The first few ships have delivered their load on the surface of the red planet. Beach umbrellas and deck chairs will have to wait because it's time to build the city and prepare for the arrival of the next group of people. The priority is energy. For this, we can use solar panels like on Earth or nuclear power plants. The next step is to build houses. Because of the lack of atmosphere on Mars, nothing will protect us from the sun's radiation. So a great option is to build houses underground. Now we need to take care of water extraction. There are ice caps at the poles of Mars. We can take water from there. Then, oxygen. Plants have to help us do that. There's a lot of carbon dioxide in the air of Mars, which serves as a kind of food for green plants. And as a waste product, they release oxygen. All we have to do is collect this oxygen and use it to breathe. Sooner or later, the food we bring with us will run out, so we'll have to grow food directly on Mars. This requires fertilizers and greenhouses. Now that everything else is taken care of, the main task is to produce fuel. We need it for vehicles on Mars and for rockets to be able to return home. Fuel can be extracted from the carbon dioxide in the atmosphere and water. All this has to be done in completely unfamiliar conditions. Gravity on Mars is 3 times weaker than at home. You'll be able to jump higher and lift heavier objects, but prolonged exposure to such weak gravity can harm our bodies. Now that there's a whole city on the planet's surface, it's time to turn Mars into something more comfortable, resembling Earth. This is called terraforming. We need to increase the pressure in the atmosphere so that water can exist here not only as a vapor or ice, but also in liquid form. We also need to raise the temperature of the surface. Our goal is about 68 degrees Fahrenheit. Right now, it's about -81 degrees Fahrenheit on average there. Then, we need an ozone layer, like on Earth. It should protect us from solar radiation. Finally, we can start creating the biosphere. That's all living organisms, plants, and animals. Gradually, Mars will start to resemble Earth in its best years. For all this, scientists have come up with many solutions. For example, a large asteroid could be dropped on the surface of Mars. This would warm up the atmosphere and bring more water and gas there. The planet could also be populated with different bacteria. In laboratories on Earth, scientists have simulated conditions on the surface of Mars and realized many bacteria can survive there. As long as they live, they can release oxygen and other gases into the air. Besides that, we can build biodomes. This is a kind of greenhouse with favorable conditions. Life will develop in it, and the soil of Mars will gradually become suitable for life. And one of the easiest ways is the greenhouse effect. On Earth, it contributes to global warming, but on Mars, gas emissions from cars and factories can help create an atmosphere. Optimistically, it could take 300 to 1,000 years to change the face of the red planet. Other scientists say it could take millions of years. Only then will humans finally be able to take off their spacesuits and oxygen masks and call Mars home.
So Mars has 2 moons, Phobos and Deimos. And apart from the bizarre shape, there's nothing remarkable about them, except for one thing. Not so long ago, scientists discovered a strange phenomenon on the surface of Phobos, and they still can't find any explanation for it. What is this phenomenon, and what does it tell us about the history of our solar system? Let's find out. American astronomer Asaph Hall discovered Phobos and Deimos back in 1877. Did you know that all the planets in our solar system are named after Greek and Roman deities? For example, Mars or Ares is the famous deity of war. That's why the satellites of this red planet were named after the sons of Ares, Phobos and Deimos. These beautiful names actually have creepy meanings: fear and horror. In 1971, NASA's Mariner 9 telescope took the first pictures. That's how we found out that these guys weren't at all like our moon. They had this weird shape, a strange and unstable orbit. Moreover, there are no other moons in the solar system that move as close to their parent planet as these two. Well, they are its suns after all. But even though they are very close to Mars, if you were standing on the surface of the red planet, you would hardly be able to see them. That's because the curvature of Mars hides Phobos and Deimos from view. Even if you were somewhere on the equator, Phobos would look like an ordinary asteroid to you, and Deimos would look like a star. All because these satellites are basically crumbs compared to our moon. They're the smallest and least bright moons in the entire solar system, which is ironic considering their mighty names. Anyway, it seems that everything should be pretty clear with these two satellites. But nope, there's a problem. You see, scientists reconstruct the history of space based on the traces found on different space objects. Dents, scratches, cracks, all these things can tell us what happened billions of years ago. For a long time, scientists were sure that, just like their Greek prototypes, Phobos and Deimos were twins. But then, NASA's Viking orbiter took new photos of the satellites, and that's when they discovered a significant difference between the two. The entire surface of Phobos was covered with huge grooves. Those were a series of long, deep pits stretching from one end of Phobos to the other. You may say, what's the big deal? All space objects have this kind of stuff on them. And yeah, there are other satellites with similar grooves and scratches, but none of them has as many as Phobos. It's completely covered in grooves, and they're huge, up to 12 miles long and 660 feet wide. And that's not all. Some of these grooves intersect with others. This means that Phobos has experienced not one, but many traumatic events. But what exactly happened to it? Actually, scientists are still not completely sure. However, they have a few ideas. And these theories can tell us not only about the past of Phobos, but also predict its future. Theory 1. Asteroid impact. Well, the first suspect is quite obvious. There's a large, almost 6-mile wide crater on Phobos. It's called Angeline Stickney. It was named after the wife of Asaph Hall, the scientist who discovered the satellites. Adorable. So that's what the first theory sounds like. Once upon a time, an astronomical body crashed into Phobos. The impact was so strong that it left a large crater. And the effect of the collision left a bunch of grooves everywhere on Phobos. It sounds logical at first. However, scientists have noticed a flaw in this theory. They learned that these grooves actually formed not inside the crater, but next to it. So it wasn't a collision that created them. Besides, what about those grooves that intersect with the others? Or is it just a big cosmic coincidence? Well, the search for truth continued. Theory 2. It's all because of space debris. Yes, there's a difference between these two theories. In this case, the grooves aren't a direct consequence of the collision. Rather, it goes something like this. Something crashed into Phobos. This impact caused a bunch of rocks to be thrown into space. Some of them were lost in the universe forever, but others were small enough to be pulled back to Phobos. Passing next to the moon at a steep angle, they would crash into it, jumping away, and so on. And since the gravity of Phobos is very weak, perhaps they couldn't stick to it. In other words, these rocks were continuously pulled toward and pushed off of the satellite for many, many years. This theory explains the intersecting grooves. It's because the rocks were constantly falling into those places. It sounds quite logical, but there's another problem. We don't see any boulders on Mars or on the surface of its moons. But all this debris was supposed to get trapped by gravity and remain somewhere in the planet's orbit. This, or simply become part of Phobos. In other words, if this were true, we'd find evidence of this theory under layers of dust. But that didn't happen, so this explanation didn't satisfy astronomers either. Therefore, they continued to look for the culprit. Maybe the grooves have nothing to do with Stickney Crater at all. Maybe the real culprit is something else. something even more powerful. Could it be Mars itself? Theory 3. Mars is a twist villain. The previous theories imply that Phobos and Deimos were originally pieces of Mars. Like once upon a time they broke away from it and became satellites, just like our moon. But what if that wasn't the case? Observations made by NASA's Mars Global Surveyor show that Phobos and Deimos are made up of elements which are mainly found in meteorites and asteroids. So, what if Phobos and Deimos are asteroids? There's an asteroid belt between Mars and Jupiter. Given the size, shape, and composition of Phobos and Deimos, scientists have suggested that once upon a time they belonged to this belt. However, one day they flew out of it, and then gravity pulled them to Mars. This phenomenon is called asteroid capture. It's very strange though. Yeah, the asteroid capture isn't uncommon, but these two have been flying next to Mars for what, billions of years? It's weird that their orbits have remained the same. In addition, the atmosphere of Mars is very rarefied, and because of this, it could hardly capture any asteroids. In theory, they should have separated from Mars at the first opportunity. However, this didn't happen. It means that somehow they got stuck, and Mars immediately began to destroy them. Yep, an unexpected twist. In this version, Mars turns out to be a villain. By studying the past, we've found some evidence of future crimes. The mysterious grooves of Phobos could be caused by tidal forces between Mars and Phobos. The Moon and Earth also exchange these, slightly distorting each other. But since Phobos is much closer to Mars, the impact of gravitational forces is much stronger. In other words, the gravity of Mars is gradually destroying Phobos. Every 100 years, the satellite gets 0.7 inches closer to Mars. It also shrinks as much as 6.5 feet, becoming even more fragile and weaker. The smaller it gets, the more the tidal forces impact it, creating strange grooves and scratches on Phobos. Yep, somewhere in 30 to 50 million years, Phobos will either collide with Mars or disintegrate and turn into a bunch of small rocks. And then Mars will also have rings, like Saturn and Neptune. That's why Phobos is called the doomed Martian moon. Anyway, these are all only theories, but the dramatic backstory of Phobos gives us an idea of how dynamic extraterrestrial objects can be. The more we learn about them, the more we discover about the secrets of the origin of not only Mars, but also other objects in our solar system. If one day we really colonize Mars, studying its moons can help us a lot. Let's hope that the upcoming MMX mission will reveal some of the most exciting secrets Mars's moons are hiding. Your alarm goes off and you open your eyes, groaning. Wait, why is it so dark? Is it still night? Your watch says otherwise. You come up to the window and see people running around in panic. Apparently, the sun has disappeared. Interestingly, people only realize it 8.5 minutes after it had happened. That's how much time sunlight needs to reach our planet. So Earth kept orbiting the recently vanished star, and people had no clue. And then the last rays of the sun reached us. What would happen to Earth, the Moon, and other planets of the solar system if the sun was to disappear into thin air? And would humans survive this catastrophe? Now, the sun is a giant light bulb supplying energy to the entire solar system. Not only our planet, but all the other celestial bodies in our star system are locked in elliptical orbits around the sun. In other words, the sun is the ruler of our world, keeping everything in balance. You see, every planet is constantly falling towards the sun because of the star's immense gravity. But there's also a lot of sideways force, aka centrifugal force, that moves the planets away. These forces are perfectly balanced at the moment, but everything would go downhill with the disappearance of the sun. the planets would still continue their forward motion and leave the borders of the solar system. Keep in mind that Earth revolves around the Sun at a mind-boggling speed of 67,000 miles per hour. If there was no more gravitational pull from the Sun, Earth would immediately shoot out of its orbit, and its speed wouldn't decrease. The same would happen with all the other planets in the solar system. They would go on and on through the dark cosmos until they found another object with powerful gravity that could capture them. It might last for hundreds of years. Now let's see what would be going on our planet. Animals would likely be the first to feel the consequences of the sun's disappearance. They would become agitated as the darkness would come way earlier than usual. Birds would become quiet, settling down for the quote-unquote night. There wouldn't be any natural light at all, even moonlight. All because there wouldn't be any more sunlight for the moon to reflect. Without sunshine, there would be no photosynthesis, so plants and trees would stop growing. Herbivore animals would soon chew their way through the remaining vegetation, and there wouldn't be any food left for them, and us. The temperatures on Earth would slowly start falling. Our planet does have a core made of molten iron covered with a mantle of molten rock, so some heat would still be filtering through the planet's crust, keeping it warm. But it wouldn't last forever. People would start burning wood and coal to fight the cold and survive, but without food, it wouldn't help much. The seas and oceans would freeze, together with all their inhabitants. In the end, the atmosphere would collapse, leaving our planet vulnerable to the harmful radiation waves roaming through space. This would make life on the frozen planet even more difficult. Most living organisms wouldn't survive these harsh conditions. Those that live beneath the surface would probably survive, warmed up by the weak heat coming from the Earth's core. As for people, we would probably have to stay in large groups, using the energy received from nuclear fusion reactors. Or the whole scenario would get much more tragic. While hurtling away into space, Earth could collide with another planet, get hit by an asteroid, or even get pulled into a black hole. Or the planet could continue traveling for thousands of years until it found another star to orbit. Now, how about we take a look at what would be happening right after the disappearance of the sun? Uh-oh, that was very disturbing. Luckily, this is a very unlikely scenario because stars don't vanish just so. They can run out of their star fuel, that's true, but miraculous disappearances won't happen.